Oh, good morning, everybody, and welcome to the Digital Business Marketplace Catalyst, Phase 3, where we're looking at enabling companies to partner to deliver Industry 4.0 and Smart X solutions. If you could please mute your microphones during the presentations and demonstrations. If you have a question, please raise your hand during Q&A, and of course, the chat function is available there too. The session is being recorded, so that you can get to the information later on after this. So I'm very honored to have the privilege to lead this DBM3 presentation. As you can see on the right of this slide, we have some 29 organizations in the Catalyst. We have several more on the wings about to sign up. The agenda for this session is quite straightforward, with an introduction to DBM3, 4 sections to share on the 4 initiatives, and followed by next steps and Q&A. So let's start. Very excited to share that actually we've got a main video on our Catalyst booth, and we're going to play it now as well. It is 6 minutes, so be ready. It's very action-packed.
Industry 4.0 market requirements for smart city, grid, entertainment, and other smart X scenarios are expanding at an accelerated rate. Is your business ready to support this rapid expansion? FortuneBusinessInsight.com predicts the Industry 4.0 market will grow to $260 billion by 2026. That's an increase of $182 billion over 2018. HarborResearch.com estimates that 15 million industrial sites are seeking Industry 4.0 solutions. The Digital Business Marketplace has developed Industry 4.0 and smart solutions empowered with the sophisticated communications and computing capabilities needed to realize this growth. Leaders in business have recognized the value they see in the Digital Business Marketplace approach. John Reynolds, CEO of Agile Fractal Grid, has stated, "The DBM 3.0 Catalyst is a very exciting program with great depth in participants and champions. We are leveraging many DBM solutions within the initial implementation stages of our mass deployment of customized fractal microgrids." Dan Isaacs, VP Technical Director for the Digital Twin Consortium, has said, "The Digital Twin Consortium is delighted to be a champion of the Digital Business Marketplace Catalyst. The changing world across many industries is rapidly adopting digital twins with significant business benefits, economic impacts, and cost reduction outcomes. And DBM provides important inputs into the evolution of digital twin technology." And David Shaw, CEO of Intuitus, has added, "Intuitus is delighted to see how DBM's blueprints enable the combination and configurability for anything as a service to readily include cybersecurity at the core of the solution, to be selected and purchased from the shopping cart and delivered securely with precision repeatability." To date, to manage and capture this expansion has become progressively more challenging as solutions become more sophisticated with higher security requirements. In addition, customers require ever-evolving, customizable, and multifaceted solutions. The Digital Business Marketplace ecosystem addresses this by leveraging a number of key technologies capable of processing thousands of products and services, all customizable through configuration from hundreds of business partners. Currently, businesses operate with tools such as order screens, spreadsheets, emails, experts, and APIs. The result is costly and complex integration issues that discourage long value chains and cause fragmentation. Utilizing a digital partnering platform with federated APIs, business and technical rules, and data models, the Digital Business Marketplace enables traditional companies and hyperscalers to seamlessly partner in a frictionless ecosystem so they can deliver secure, zero-touch, Industry 4.0 solutions for complex customer requirements. Customers will benefit from an ecosystem of partners that provides a greater choice of secure solutions, lower costs, and a better experience from solutions that meet their exacting needs. Sellers and agents will benefit from frictionless, trustworthy partnerships, efficiency gains, lower operational costs, and certainty of payment. Through the TM Forum Catalyst program, the Digital Business Marketplace, or DBM for short, has been able to mature this ecosystem and prepare it for commercial release. How does the Digital Business Marketplace ecosystem platform work? DBM is a platform as a service that is available globally from the cloud. Each business partner within the marketplace will benefit from core capabilities such as digitization of business offerings and commercial operations, use of multi-party trading, distributed ledger technologies, zero-touch device orchestration, and the latest in self-healing managed cybersecurity framework. A DBM partner can choose to take any role in the ecosystem, whether that's as a supplier, wholesaler, retailer, agent, or any combination of these. Partners can easily integrate their products and services into the ecosystem platform while maintaining their own fulfillment, assurance, and billing systems. Once the partner's catalog has been integrated into the ecosystem, their products and services can quickly be aggregated into solutions that can be sold through the partner's own storefront or distributed using an agent. Those solutions can be bundled with solutions from other partners and be distributed to either retail or wholesale customers. Partners can choose the partners they wish to align with and customize the details of their trade agreements. Utilizing this model, any DBM business partner can quickly and easily generate additional revenue streams. All of this can be achieved effortlessly using the frictionless DBM ecosystem platform. We call it frictionless because each partner uses the same core capabilities, ensuring the same automated approach for monetization, delivery, deployment, maintenance, etc. is used throughout the value chain. Utilizing insights gathered from earlier and ongoing work, the DBM Catalyst is now reaching the end of Phase 3, which is focused on productization of the ecosystem platform. During Phase 3, the DBM adopted a team of teams approach, operating as 4 smaller teams or initiatives. 3 of our initiatives have tackled smart grid, smart entertainment, and smart manufacturing use cases. The 4th initiative has tackled the secure supply chain use case, which is fundamental to all Industry 4.0 and SmartX scenarios. Secure supply chain forms the part of the smart infrastructure needed for the secure and zero-touch deployment and management of all devices and services across the ecosystem. The digital business marketplace currently has 29 organizations supporting the DBM initiatives, and in addition to the initiatives already mentioned, has sights on developing further SmartX use cases. Accelerated expansion can present many challenges. The digital business marketplace has developed an ecosystem platform to overcome and even benefit from those challenges. The members of DBM welcome you to explore what the digital business marketplace can do for your business.
So there's a lot of information in the video, so I hope you're all still with us. Of course, the DBM team are very excited about the quotes in the video, and we have some other quotes we did not yet share, and we hope to have more information on various projects over the next weeks. For example, David Shaw, CEO of Intuitus, is nurturing a smart city project in Africa, encompassing several of the DBM3 initiatives. Before I hand over to the team to share the DBM initiatives, this slide will hopefully help to clarify how we're using words such as initiatives, verticals, infrastructure, and secure supply chain. As the video indicated, secure supply chain is part of smart infrastructure, which is key to enabling all smart verticals. So a key question at the beginning of Phase 3 was how to share out the work, given all the verticals need smart infrastructure. We decided to use a team of teams approach and tease out and explore different facets of the same repeatable solution patterns across 4 different scenarios. And if they all worked the way we anticipated, then all we needed to do is to bring them together to deliver end-to-end Industry 4.0 and smart vertical solutions. It was also deemed best to call these 4 areas initiatives to help people understand that these are pieces which need to come together. As you run through the initiative presentations, you'll see how some of the smart infrastructure has been used in the secure supply chain initiative, and other parts of smart infrastructure, as seen on the bottom right of this side of the slide, have been explored in the smart vertical initiatives. So now let me hand over to Gary Roos to share the secure supply chain initiative.
Thanks, Andrew. I'll just take over the screen. So you see my slide okay?
Yep.
Brilliant. Okay, so we saw at the start of the video, the Industry 4.0 market is expected to grow to $260 billion by 2026. However, this expected growth is being held back because Industry 4.0 and Smart X scenarios are dependent on secure and frictionless smart deployments, which in turn are reliant on secure and frictionless supply chains, which currently isn't the case at this moment. Supply chains still remain vulnerable to issues such as theft, fraud, damage, delays, and poor synchronization between supply and demand. And we also heard in the video that Industry 4.0 and Smart X scenarios are constrained by market sector fragmentation and with costly and insecure labor-intensive processes, which compound the problem. As a result, Industry 4.0 and Smart X deployments will struggle to scale until the supply chain evolves into an ecosystem that can repeatably deliver secure devices, services, and solutions which can be easily aggregated, offered, ordered, delivered, installed, managed, and monetized. The Secure Supply Chain Initiative has addressed many of these issues by blending together a number of technologies, such as distributed ledgers, a commercial ecosystem, security, secure device onboarding, and zero-touch orchestration. The high-level goals of this initiative were twofold. The first goal was to enable product managers to offer and aggregate products and services along any length of supply chain to provide customers with feature-rich and configurable solutions that match their requirements, and to make those solutions available to the customer right from the shopping cart, no matter what sector they work in. The second goal was to enable the hardware, software, and service providers within the ecosystem to securely and frictionlessly deliver and commission their products and services as parts of a fully integrated solution. In this case, sending bare metal devices to a customer site, provisioning the network connectivity services for the site, and downloading and configuring all the required software on the devices. This is a high-level picture of what we built. There's a lot to take in one go, so I'll break it down into a number of layers and explain it that way. Starting with the commercial layer, there are a number of provider actors shown in red and a number of customer actors shown in blue. In our scenario, the customer orders a solution bundle from the multinational retailer. The bundle is composed of a UCPE, a router, a surveillance camera, an IoT controller, network connectivity, zero-touch services, software, and a secure delivery service. We assume that the retailer doesn't keep a local stock of devices and that all devices will be drop-shipped to the customer directly from the providers holding the stock. The retailer helps to fulfill this order by ordering commodities from the software providers, the hardware vendor, the CSP, and the global supplier. The order to the global supplier is for the UCPE, who doesn't have it in stock, so orders it from the global exporter, who also doesn't have it in stock, so orders it from the US manufacturer, who does have it in stock. Two things now happen, one in the virtual layer and one in the physical layer. In the virtual layer, the UCP needs to conform to the FIDO SDO standards so that it can be securely provisioned with zero touch. This means that the US manufacturer needs to provide a digital ownership voucher for the device. The ownership voucher will be used later on by a device management server to claim the device, establish a secure connection with the device, and fully commission the device. The ownership voucher is extended and passed up the value chain to the retailer whilst maintaining full ownership provenance. Similarly, the hardware vendor does the same, providing the ownership voucher and passing it up the value chain to the retailer. At this point, the process in the virtual layer pauses. Meanwhile, in the physical layer, the devices are transported to the customer's goods inwards area. The devices are tracked and traced, and all the information such as invoices, locations, and transport documentation are immutably recorded in the device's digital twins. The devices are then collected by the authorized installer, who does the physical installation at the customer site. At the same time that the devices are collected by the authorized installer, a trigger is sent to the retailer to resume its virtual layer processes. The ownership vouchers are now sent to the device management server, or DMS, which is acting on behalf of the customer. The DMS then registers its customer's ownership vouchers with the trusted SDO rendezvous service to claim the devices, and the system is now primed and ready for the devices to be powered up. When the devices are first powered up, the devices contact the rendezvous server, who redirects them to the appropriate DMS. A secure connection is established between the DMS and the devices, and then the DMS fully downloads and commissions all of the software and configuration on the devices. We'll now show you a short video of the demonstration. Andrew, I think you're going to be doing the honours for that, please.
Sure, can do. We screen share back.
There you go.
We start with the customer selecting and configuring the bundle from the storefront. This customer journey includes configuring device bundles, adding network connectivity, and also adding zero-touch orchestration to the selected devices. An example zero-touch service is zero-touch bootstrapping, which enables software and configuration to be automatically loaded onto bare metal devices. After the order is placed, the retailer decomposes it into suborders and sends some of these suborders to its ecosystem partners to help complete the order. This animation is used to visualize the implementation. The path shown in the animation represents a suborder journey that travels to the US manufacturer. Once the suborder reaches the manufacturer, the ownership voucher is transferred up the supply chain to the retailer. Meanwhile, we see the physical devices being transported to the customer via various distribution hubs and customs areas. Note that both of these physical and virtual journeys are secured by different distributed ledger technologies. For the physical journey, we track the devices using a mix of technologies such as 4G, RFID, and barcode scanners. And with the assistance of digital twins, authorized actors can see the location of the devices and any other relevant information associated with them. The devices are tracked to the customer's goods inwards area and then further tracked to the third-party installer. When the devices are with the installer, the ownership voucher is transferred to the device management server, or DMS. The DMS now calls the SDO rendezvous server to claim the devices. The system is now primed and ready for the devices to be powered up. We now see what happens when the devices are powered up one by one. They each contact the rendezvous server, which redirects them to the appropriate DMS. A secure channel is established between the DMS and the devices, and then the devices are fully commissioned with the requested software, certificates, and configuration. Lastly, we see a fully operational solution as expected by the customer.
Thanks, Andrew. I'll just grab the screen again if that's okay. Okay, so I just wanted to end on this last slide, which shows the main organisations who've been involved in bringing together this solution. So I'll now hand over to Mo, my colleague at BT, who will be covering Smart Manufacturing Initiative.
Thanks a lot, Gary. I'm really honored to be here with you guys on behalf of my team in Smart Manufacturing for Digital Business Marketplace 3. We have collaborated around the most inspiring and groundbreaking industry transformation in our lifetime in this catalyst, and we have brought together the key enablers for Industry 4.0 vision. So all of the Industry 4.0 enablers we're going to mention in the next few minutes are going to shape the future of manufacturing industry verticals.
The manufacturing industry is changing. Products are no longer built by the hands of humans, but instead by harmoniously synchronized robots, each connected to the network. But with the increasing complexities of Industry 4.0, can our current systems keep pace with this incredible step change? And can more be done to customize private network slice connectivity within manufacturing? Getting data to the right places, in the right amount, securely, and at the right time.
We are delighted to have MaxByte as our Industry 4.0 specialist in this catalyst. MaxByte offers solutions for a number of use cases in industrial IoT. The Digital Business Marketplace Catalyst has provided MaxByte the opportunity to validate the promise of zero-touch frictionless partnering, so that they can transform the way that MaxByte services its customers. DBM capabilities with zero-touch solutions as a service would help MaxByte's current Industry 4.0 self-service platform development. This enables MaxByte solutions to be securely deployed, in life managed via digital twins from cloud to the edge, leveraging their Industry 4.0 Byte Factory platform via TMF APIs, delivering factory as a service, M2M transactions, robot healing services, leveraging capabilities such as AI, DLT, cyber agents, with granular monetization for all MaxByte partners using the DBM digital platform. Let's see how we have achieved this. The world is being dominated by the digital natives, and industry verticals including smart manufacturing now expect to be able to buy and manage anything as a service, vendor and service agnostic, from single shopping cart. Together, we have developed a set of technologies in which local private networks and edge gateways can be ordered, delivered, installed and onboarded to the management platforms and bootstrapped with operating systems, applications, NFV and SD-WAN capabilities, using our revolutionary and collaborative zero-touch bare metal onboarding technology through a secure supply chain.
The order journey starts progressing down the various value chains of the bundle components being fulfilled within various tenants in the supply chain.
In this 5G connected world, anything will be possible, with smart factories with private secure networks allowing multiple users to simultaneously use and benefit from assembly lines and infrastructure with ease and total reliability.
These set of technologies for smart manufacturing are empowered with feeless microtransactions and data integrity for machines, cryptographically secure in a decentralized way. And with communication happening machine to machine, distributed ledger technology (DLT) is being used for any sort of information transfer during the production processes in the smart factory. On top, we have developed the digital twin, which includes digital representation of everything in the factory. This introduces data-driven production strategy and ensures machines are running the correct software, and enables continuous and precise data analysis and predictive maintenance. In the factory, machines are acting autonomously, earning and paying digital money for their services in exchange of materials and other resources in the real time. This fully intra-connected system reacts to its condition and performs instant self-optimization.
What you are seeing here is our zero-touch portal, a new technology that allows users to seamlessly order and provision a private network for a smart factory. To input what they need, when they need it, and where, all online and at the click of a button. This private, fully customizable slice gives a new level of personalization and oversight to network slicing. Easier, faster and more reliable than ever before. We also offer additional add-ons, allowing for confidential protection and AI support, as well as edge hardware and IP network communication packs. And that's it. Now you have your own dedicated slice of the network ready to be deployed. Now you can control an almost unlimited number of robots within the manufacturing process, each connected to your own private, dedicated and secure slice of the network. This self-balancing robot is controlled through edge intelligent technology on an ultra-low latency communication slice. It is monitored via the drone through the enhanced mobile broadband slice for real-time streaming to a central office.
As the next step, we have innovated Self-Healing Network (SHN), an intent-based microsegmentation (IBMS) with service assurance on top, which is able to identify, protect and mitigate security threats continuously and automatically across all the devices and networks in the smart factory. Self-healing mechanisms including sliced and segregated network VLANs, northbound, southbound and self-protection are few examples of this offering. The contaminated device in the factory's network can get immediately flagged out and isolated. The self-healing mechanism can detect and remove the malware automatically from the device. And trust to the affected device can be built back through few stages, governed by our security service assurance services. All these mentioned Industry 4.0 enabler technologies shape the future manufacturing industry vertical.
Thanks a lot. I hope you enjoyed this cutting-edge technologies pulled together from colleagues from different organizations in the Catalyst. I pass to John Reynolds, the CEO of Agile Fractal Grid, to talk you through these smart grid solutions. John.
Well, thank you very much, Mo. First of all, delighted to be with you. In the sequence of the story here, we've seen the basis of the secure supply chain. We've seen the smart manufacturing activities. This particular section is going to talk about what we're going to do at a little bit higher level using some of these devices that have been made through this particular process. The smart grid, as it's been explored with the Catalyst here, has about 4 tiers to what's going on as far as a national look, as far as how a smart grid might be put together. We're actually building this piece at a time in the United States, and it's going to be actually going on in other countries also. But essentially, the 4 tiers here are microgrids at the bottom, which we call tier 1, and they have an aggregate of various capabilities for each one. They operate in clusters we call tier 2 for a particular district of a city or a military base or that sort of thing. There's a 3rd tier that handles all the money relative to the regional operations, since they're slightly different depending on which region you're in. And then there's a shared consciousness at the top. And so what we'll do is we'll explore each one of these pieces so that you can get the feel for why the tiered approach is very helpful as far as the deployment. Should we go to the next slide? At the tier 1, each of the microgrids, an example would be one of the initial ones going in, has about 47 microgrids that are each independent as far as what's going on. They can stand by themselves, operate totally any way they would like, independent of the rest of the world. They are able to generate their own power. They have their own very high-speed communications that they operate. They have their own edge computing capability, and each represents a cybersecurity enclave so that they can operate totally isolated from the rest of the world if they want to. But as it's come together in the arrangements, let's go to the next slide. These microgrids operate as a team, and at the 2nd tier, we have a controller that actually is operating the cluster of microgrids, such that if anyone fails for any reason, some catastrophic problem or something like that, it's automatically rebalanced within about 1 second, so that the entire operation continues despite the fact that you may have had a problem at a particular individual microgrid. So let's go to the next slide. While the Tier 2 operation is primarily there for operational purposes, the individual microgrids can sometimes generate far more power than is actually used locally by the district or the individual locations. So this excess power can be gathered together through storage techniques, and each of these Tier 2 arrangements can become virtual power stations. And so the way this works is that at a regional level, you can dispatch the various power back into the grid. You can operate against the market to buy and sell electric power and support what's going on. You actually have to be able to measure what's going on to make sure that you're doing what you said you were going to do. But this is where most of the money is made in the electric grid, is in buying and selling power on the exchange for other people who need the power, especially those who want carbon-free power. Let's go to the next slide. Now, there's some things going on in which you want to have a national shared consciousness of what's going on. These have to do with the balance of electric power to make sure it's smooth and uniform across the entire United States or the country that you're operating in. You'll have communications aspects to want to monitor what's happening with your ability to interconnect. And you'll also have a cybersecurity arrangement, which we'll talk about, to be able to monitor what's going on from a cybersecurity standpoint and to be able to take action where necessary at a national level. Let's go to the next slide. Now, the interesting part about this is in the rollout is that you would need to be able to semi-custom design each one of these microgrids, because no two are the same. You can make them all out of the same types of patterns, but essentially the mass customization process, as far as the manufacture, deployment, installation, operation, we use the digital twin to actually do this from the mass customization replication centers, of which we'll have several around the country that operate this way. Go to the next slide. The digital twin structure itself is a little bit bigger than your normal digital twin that people talk about. There's actually about 3 sections to the life cycle as far as what's going on in the beginning. On the left-hand side of this approach, which is brought to us by City Zenith, you have an area in which you need to be able to engage with the public and other groups to be able to just participate this at all. We find that when the public actually participates in the design and implementation of their own mechanisms, they very much love it and will do a great job of it, and will customize it to their own needs, and they will defend it to the death. So the experience that takes place out on the left is very, very important to get something going where you have a massive deployment such as this. Now, the middle of the digital twin is the more traditional type of activity, where the building information model arrangements, other construction activities are being managed at a physical level. So these are all typical. On the right-hand side, as you get everything put together, there's the logical and the cognitive activities that have to take place. So this is where the various services are being applied relative to the physical infrastructure that's just put in place. So it's the entire life cycle is important here for the digital twin. Let's go to the next slide. Now, part of the use cases we're doing is to operate in a fault-tolerant mode because of the extreme inconvenience when the grid goes out as far as what's going on. Here we use a 5G wireless service to back up the wired paths that's going on. We use the fault-tolerant DTWS protocol, which is now standard for the industrial internet, as well as the electric grid open field message bus, at least in North America. And we're using the Stratus fault-tolerant edge devices to actually operate what's going on, so that you have a degree of fault tolerance within the Tier 1 microgrid. Actually, with the way the rest of it's wired together, it becomes fault tolerant at the upper tiers too. Let's go to the next slide. extreme volume of processing is unbelievable in this, with the way it's put together, where you manage from the edge and in decentralized fashion. You have lots of measurements coming with the new synchrophaser operations, precision measurement units. You're taking about 120 sets of measurements every second, and those come in to monitor all kinds of things as far as what's going on the grid. And so we have kind of a relay mechanism in which we store and then summarize, store, summarize, store, summarize up the various tiers, so that you can deal with the billions of events that are actually taking place without getting swamped as far as what's going on. So the phaser data concentrators are the mechanisms that handle this tiered relay, and the real-time distribution management system is what's watching what's actually going on and allowing the shared consciousness to take place on the electric operation. Next slide. We use distributed ledger technology for handling some of the trades that take place locally between the producers and the consumers of electricity that are operating in this distributed operation. The trading back and forth allows everybody to share excess power that they may have with their neighbors and be compensated properly for what's going on in a very safe and uncomplicated way. Next slide. The security system really uses a closed loop approach. On the left, you have devices that are operating, and they pass various information up. Either explicit security violations are detected, or trends of behavior are observed, and they come up to a security operations center run by Intuitus. For this arrangement, we have collaboration with other parties to be able to watch and see what's happening nationally at the shared consciousness level. And then we can use the digital twin for the modeling and simulation function to decide what kinds of change are going to be effective going in and monitor for unintended consequences through the simulation exercises. Our DevSecOps arrangement that's put in place is set to change the grid, and while it's operating, no need to stop it in order to make changes as far as what's going on. So we're able to inject changes and maintain what is known in the military as continuous authorization to operate without ever stopping anything for the security operations. Next slide. So these are the folks that we have worked with and brought to these individual pieces, kind of arrayed at the different tiers in which they're operating. This is truly a team of teams. Just want to thank everybody who worked on this particular arrangement. We're going to proceed to put this into actual production as we go forward. So at any rate, this is the team. This is the 4-tiered operation, and this is the smart grid. Okay, Andrew, off to talk up.
Thank you, John. First of all, thank you so much for this opportunity. We have a video which explains smart entertainment workstream shortly. Andrew, please play the video.
Hello, I'm Taka Nakama from NTT Group. Thank you so much for your interest in Digital Business Marketplace Phase 3 Smart Entertainment Vertical. This vertical focuses on use cases in entertainment industry, such as theaters, sports stadium, etc. First of all, to capture the expectation of the vertical, we would like to start with a short video. Mr. Ado Machida, Hard Rock Japan, shares their plan in Japan.
We have almost 225 cafes, and no longer really just a cafe business, but really an integrated resort operator. We now have 29 properties across the globe, of which 11 have casinos. I'm president of Hard Rock Japan, where we are focused on doing a integrated resort in Japan. Our primary priority was in Hokkaido, still is. The project itself, we're looking at probably a $3 to $4 billion project investment initially in phase 1. Our chairman has said up to $5.5 billion, but we're looking at that over the course of the 10-year life cycle. we also have in Florida, the Hard Rock Stadium, where we have a seated capacity of 65,000. We recently had the Super Bowl there in late January of this year, where it was packed to capacity. We've also had concerts there, but while I can understand your technology from a conceptual level, I'm still trying to understand how we can bring the level of energy and excitement to the hotel room.
To explore the vertical, according to Mr. Machida, especially under this COVID-19 circumstance, we focus on providing new hybrid experience in various situations with the scalability in terms of the number of participants, e.g., hundreds at theater, thousands at conference-type event, tens of thousands at stadium, which may be available at home in addition to the event site. In addition to the aspects provided by Mr. Machida as a vertical, we also need to take into account the problems at service provider side, such as cost and complexity. In order to solve these problems, we propose this frictionless marketplace with zero-touch onboarding and device management capability. Illustrating smart theater as an example, the picture at the left-hand side shows Japanese traditional no-play at theater and synchronized script through bundled services over rental tablets to understand what is performed in appropriate language. As you can see at the right-hand side, to enhance the customer experience, portal site enables to consume various services across theaters. Live chat allows the interaction during the performances. Rich content option encourages personalized experience through bundled services at the business marketplace, including a shop to buy gifts and memorabilia. All offers can be consumed both on-site and at home. The use case in the previous slide is realized through this marketplace, which we propose as Smart Entertainment Workstream. There are three main characteristics which we'd like to emphasize from a smart infrastructure aspect. Efficiency. Simplified interaction through portal zero-touch onboarding with device management service and agency for both theater and service provider. Reliability. The secure platform for both ends provided by telecom. Scalability. The cloud-based platform with variable capabilities to different use cases. At CSP, it's critical to create new revenue streams among partners with horizontal solutions targeting other verticals. Historically, providing such services is complicated due to the needs to assemble many solutions in addition to the collaboration with partners and to solve and simplify identity federation. Managing who has access to what and with what authority. For all SMBs and digital tool providers, to manage and enhance customer experience is essential. Supporting it from an underlying platform helps all players at the same time.
Thanks, Taka. Smart Entertainment will provide very important capabilities in a post-COVID world, and NTT's natural leadership in this area, stemming from the smart theaters expertise, is very significant. So let me move to our last slide. So the DBM team has got some actions going forward. We're going to submit contributions spanning the TM Forum frameworks, articulating the blueprint details, which we've illustrated here in this work and this presentation. Of course, the APIs used and other assets created. We're also going to establish a long-run digital business marketplace program under TM Forum Charter to support the ecosystem's contracted delivery and leverage the TM Forum's Open Digital Lab. And of course, we're looking with excitement at the AWS reInvent 2020, which is due to take place in November, where we will evolve and demonstrate aspects of this catalyst. So really, in summary, we'd like people please to visit our digital business marketplace booth within DTWS, review the lead video, the 4 initiative videos, and the supporting materials. And of course, the supporting materials actually point in URL links to our own site, which we've created to support these very initiatives, so dbm4.net, and within that site one will find the various working materials, champion quotes, business impact statement, innovation insights, the Osterwalder work, and of course the various supporting materials that have been created by the many participants and champions who have worked together, not just in phase 3, but also in phase 1 and phase 2 as well. So hopefully this has been helpful, and we're looking forward to any thoughts and questions that people may have. Let me turn it back to yourself, Gary.
Thanks, Andrew. I was just looking in the chat, and we don't seem to have any questions in the chat, so I guess we'll just open the floor for anyone who'd like to ask any questions.
Okay, sounds good.
And we had a question from Lester Thomas. And Lester's asking, what is the key contribution back to the TM Forum for this catalyst? So Andrew, do you want to answer that one?
So there are various categories which TM Forum looks for within the contributions for the contribution award, and essentially the team are looking at actually putting a contribution through for each of those categories. So we've got line of sight to doing that, and over the next 6 weeks that will be part of the background work as we move to establish the charter for the ongoing work to actually ensure that we do submit those contributions within line of the outstanding contribution award type framework, if that helps.
Thanks, Andrew. I guess I've got one question while people are thinking. For phase 4 of the catalyst, I guess first of all, are we thinking that there's a strong motivation for phase 4 of the catalyst, and if so, what topics would be covered within that catalyst?
So I think one of the slides we had earlier on in the presentation points to, as it were, the additional verticals which could take advantage of the core capabilities within the smart infrastructure. And certainly there are several ideas that are coming in from various members of the champion team and the participants team, but also from external players too. So I think, yes, we'll see potentially a phase 4 catalyst. As we just indicated on this last slide, we also have the objective to be ready to support any contracted deliveries which may eventuate, given the work that's been done in finalizing as it were, the blueprint designs. Clearly, there's some production hardening to be done still, but the blueprint designs are very much ready to move forward to support deployments.
Thanks, Andrew. Feel free to do so. One from Use. When will the recording be made available and how? So I guess that's probably a question for Shen-Fang. How do we make these recordings available to everyone here and beyond?
Recordings, yeah. If the team would be willing to do that, it's possible to add it to the booth once it's ready.
Okay, yeah, we'll do that. We'll do that as soon as possible.
Yeah.
Thank you. And I'm not sure if there's a question from Hakon. Hakon's saying, consider, if not already covered, from application level service assurance mapped to and integrated with network level SLAs and service assurance.
Yes, sorry for joining late, and I can elaborate if you want to, but
that'd be great.
Yeah, so for what I've seen, and again, I didn't catch the very first overall video. So we are indeed discussing a lot about 5G in general, all this great connectivity that is put into the market, and all these things that are enabled. And then we also speak about service assurance, but from an application level point of view. I was thinking maybe just to mention that, or how these platforms enable also the mapping onto the more network level SLAs and service assurance. And of course, consider whether this is a relevant question or not.
I'd say it absolutely is. It's a very, very valid point, and it's exactly what we look at in terms of the whole cybersecurity and the management of every single device across any of the customers' implementations at any site, or even if it's not at site. This is absolutely part of the focus.
I think if I could just add to that, if you go back to the smart grid activity where you have the different tiers, essentially what's very important as far as the shared consciousness is to be able to monitor all the different things going on, as opposed to a silo of just the application service assurance or the network service assurance. You want to have the ability to see everything that's happening. You sometimes separate the security arrangements as far as those things that are very delicate, needs to be handled individually, but you want to see the results of those back to the operational environments for both the network, the application, and various storage types of activities. So you get to see that at the shared consciousness level at Tier 4.
Right. Yes. So from a high level, I think this is quite well presented. I was just curious whether these coming from the application level solution provider point of view, if we should somehow mention that the way this can be connected to the network level service assurance, solution provider. I assume that there is some integration challenges there that the people might be curious about.
Well, I think so. If you take, there are different applications, and each one has a different specialty associated with it. But take the energy applications where you're monitoring the operation of the grid or performance in the markets of how the money is actually flowing. You want to be able to see that, but you also want to also have a screen that shows you what's happening with the network, what's happening within the operational environment, the computation elements. So although you have different areas of specialty, you also want to be able to have a vision of what's happening side by side. It's very helpful. It really eliminates a lot of finger pointing.
And I think, John, what you've also identified is that the digital twin will actually need to have, as it were, a full understanding of all the assets' performance right from top to bottom, because if it doesn't, it could get caught out and get a cold and actually cough and splutter. So there is a need to actually have a full end-to-end assurance and understanding of everything that's moving anywhere within the ecosystem.
That's right. We have various groups that want to make changes based on problems they see. The problem with introducing a change back into the environment is you may have unintended consequences. So one of the uses of the digital twin is to be able to play in advance some of the changes that you might not be quite so sure of, to see what the outcomes might be before actually affecting it. And then after you affect it, you watch to see what happens to see if there are unintended consequences that you were not able to measure. So it's very much a continuous loop type of arrangement.
And to add to that, so one of the things we've been discussing together with John and the digital twin teams is to how to take advantage of the full service catalog versioning within the Infinova platform across the ecosystem. So the actual changes that might be offered up to the digital twin can be versioned. So the use of the APIs between the TM forum type environments and the digital twin are going to be critical in managing those sorts of assessments and ensuring that they're properly instantiated on moves, adds, and change type basis.
Okay, yeah. Thanks a lot for elaborating. Yes.
Thanks, guys. So we've got one more question from Sahand. Could you please explain the scalability of smart manufacturing example? Thank you. And I think that's probably one for Mo.
Hello. Can you hear me?
Yes.
Good. Yes. If I understand the question properly, it's a very good question. So one of the issues we've got in smart manufacturing and the smart X industry in general is bringing the scale to the deployment of the IoT and IT devices, and also the software stack on top of them. So we are talking about, installation of hundreds or thousands or tens of devices like edge devices, cameras, robotic arms, or any other routers, for example, any other network devices. And the scale issue is important because the manual work actually needs to initiate and onboard these devices into the backend systems. As McKinsey says, it's around 20 to 25 minutes per device. And the simple calculation shows that our current systems are not scalable. So with Intel, BT has a solution. We call it zero-touch onboarding, and this zero-touch onboarding suite takes care of automatic and secure provisioning of these devices at a scale into the network, and it consists of like edge, like sensor networks to the edge and edge to the cloud. Hopefully, I could answer you in a nutshell.
Yes.
Is that okay, sir?
Yeah, that's clear. Thank you.
There's a question in the chat.
Yeah, so I'm just looking at the chat. So, we had a question from well, a couple of questions. One from Michelle Natty, and one from Lester Thomas as well. I think Michelle's one was answered. So he was asking around the use of IoT technology, and yeah, we're definitely using IoT technology in the secure supply chain at the physical layer to track the devices. We're using it in smart manufacturing for e-wallets for factory machines and for micropayments, and we're using it in smart grid for the energy transactions. So I guess I think we've got a question there.
Yes, so the phase 4, how long the period is going to be for the phase 4 that we can consider to work on the augmented reality or mixed reality headset on the use case?
So I think phase 4 is going to go back to the normal schedule if the COVID world starts to stabilize a bit, which would see us, actually I should even bring up the next, because hopefully we'll be in Copenhagen face-to-face in June next year or May next year. And so phase 4 would move back into a normal catalyst phase, which basically is a 6-month process. So we would need to write a charter, submit it by sort of middle of December, which would articulate what we want to do in phase 4. And then assuming that we get authorization, of course, in parallel, as I've already mentioned, our objective is to establish a chartered program in which we can continue to work, particularly as we're looking at the AWS reInvent activities. But in terms of the catalyst for the phase 4, we would need sign off from TM Forum to be able to go ahead for a phase 4, have the right number of participants committed to, as it were, support the financial framework expected by TM Forum, and then we would hopefully be presenting and be able to party face-to-face in Copenhagen in May or June.
That's great, thank you, Andrew.
Thanks, guys. Are there any more questions?
Maybe just to touch on the plans for the phase 4. There are additional verticals that people have asked to add to the catalyst as it expands. As far as what's going on, we have the smart healthcare arrangements. We'll have a smart transportation. We'll have a smart public safety type arrangement. There's several that we're addressing right now to make a decision on, but I think you'll see this expand to additional verticals. They'll all use the same smart infrastructure that we've put together, but I think you'll see an expansion of the vertical value chains that are explored.
And just a follow-on question then, John, because clearly this catalyst is quite a large one compared to other catalysts. Do you think that there's a maximum kind of ceiling with regards to the amount of work that can be done within a single catalyst, i.e., should we be thinking about doing multiple catalysts?
Well, the good thing about this is that they're synchronized. They work with each other. This is an integrated plan that's coming forward, and it makes things much easier when you do that. I think just for time purposes, we could divide this up into several, but I think the the ability to work with each other as a team of teams is a very valuable thing. Also, the expansion of the digital twin will take place. We have about 200 organizations that are part of the digital twin consortium that Dan Isaacs leads, and they're very interested in participating further in this. So I think you'll see a richness in terms of the integration of all the thinking, but just for the time it takes to actually see what's going on. It might make sense to have multiple catalysts, but to coordinate them.
Great.
Yeah.
Great. Hopefully next time we can get 50 or 60 companies.
Or 100.
Oh, 100. Aim for 100.
Very good.
There's no more questions in the chat, but feel free to unmute yourself, and if you've got any kind of burning questions or comments, then please fire away. Otherwise, I'll pause for a little while.
And clearly, we'd be delighted to run more specific sessions on any of the topics we covered here. So don't hesitate to send a mail to our booth or to any of us. And we'd be delighted to get our team together any time of day or night to answer questions.
Yeah, and we can give you a bit of a tour of the websites as well, and to run through various demonstrations. That's no problem. Okay, did you want to close, Andrew? We haven't done this before, have we?
I think just to thank everybody for joining us. We're very excited to have had the opportunity to share this today, and hopefully we'll see you again on some more discussions between now and the next few weeks. But in the meantime, keep safe, and we'll obviously we've got this hope about next year all being together, sharing beers and wines in Copenhagen. But hopefully we'll party in the meantime. But anyway, thanks again for joining us today.
Take care, everyone. Thank you.